Hello ELT132, this is Roger Young, and this video is going to be on bidirectional shift registers. So when you have a shift register, obviously you can think of it. If we have 4 shift registers like we show here, right? We can just show, for example, suppose each of these is a D flip-flop, right? This is like a 4-bit register, right? And the other one right here. So the output of this one is, in this case, we're shifting to the right, is going to this one. The output of this one is going to the input of this one. The output of the third one is going to the input of the fourth one. And then this one is just going to shift off into bit land. Who knows where it's going to go? But the point is, this is a shift. This is a shift right. Okay? Now, let's draw this again. Exactly the same way. 1, 2, 3, and 4. I could draw 8 of them, but 4 is good enough. How about if it goes like this? Suppose the output here, when you clock it, right, it's going to shift this way. And it's going to shift this way. It's going to shift this way, right? This means, since this is the output of the chip, this is somehow going to have to, I'm going to draw it down, come down, go around, and go in the input, right? And the output here is going to have to come down, go over, and come to the input here. And the output here is going to have to come down, go over, and go to the input here. The point is that after each clock pulse, the value that was in this one is going to move here. The value that was in this one is going to move here. The value in this one is going to move here to the left. This is called a shift left. All right? So one of these shift registers shifts to the right. This one shifts to the left. You don't have to worry about the wiring so much right now. Just take the big picture that when you clock it, in this case, this one right, whatever in this one right here is going to be here. Whatever was in this one is going to be in this one, this flip-flop. Whatever the value was of this flip-flop is going to be in this flip-flop. And I'm talking about the Q values, all right? Now, if you're talking about shifting left, it just shifts the other way, right? Just like we talked about. So those are 2 types of shift registers, right? One shifts to the left and one shifts to the right. Now, let's talk about another kind of shift register. Suppose, let me get the pen back here. Suppose we have a shift register like this. Now, don't worry about the inputs or outputs here. Just suppose we have data feeding each one of these, right? It's not coming from the flip-flop to the left of it. It's not coming from the flip-flop to the right of it. It's coming from another source. And you clock pulse it once. One clock pulse, this whole register here, each one of these is filled with the values at the inputs. And then you clock it again, and then these all exit, and they're replaced by new values. This is a parallel shift register, all right? You know what? I even drawn that right. P-A-R-A-L-L-E-L, right? So this is a parallel shift register as opposed to the shift right and shift left, all right? So now what I want to do is I want to go over with you. Let me close that off there. This is an example in the text of a bidirectional shift register. And this shows the wiring, right? Because you may have some questions about that. But let's just take a look at it. So if you notice, you have AND gates here, don't you? Every input to the flip-flop has 2 AND gates. They're going to an OR gate, and they feed this one, right? Feed the D input. So each one of these flip-flops are enabled or disabled by this item up here, right? This network, I'll call it, up here. So let's just look at it this way. Suppose we're going to enable the flip-flop on the left, and I'm just going to mark each one of them. I'm sorry, I got to make this here. Let's just mark the left one, all right? 1, 2. Suppose the ones I'm marking, the leftmost AND gate, is enabled. If these are enabled, that means that this value, this line right here on each one of them, right here, and right here, they all must be high. So in this case, your direction, I'm just going to draw an input here as an up arrow. In other words, it must be high. That enables these gates. However, let's look at these gates. You see this knot here? This means this network here, this line here, that's going to be low, isn't it? That means these gates are all going to be disabled, right? So what's going to happen then is if this is enabled and we're feeding an input here, the input's going to go through this AND gate, because remember, if it's enabled, if this input is a 0, this output here will be a 0. If this input is a 1, this output here will be a 1. This is going to go right through the OR gate, right, into your D input. So when you clock it once, whatever was at the input is going to be here. Now, when you clock it again, obviously, if the input changed, it's going to come right over there. But what about this output? This output now has to somehow get over here. Well, let's follow it. Here's your Q output. It's going to come up here, go to this AND gate, right, which is enabled. We mark them, remember that? The output of this AND gate is going to go through this OR gate right into D, right? You clock it again, well, this output again is going to go right up here into this AND gate, which is enabled, right? Down through this OR gate into the input of this flip-flop. And then we clock it one more time, the same thing's going to happen. It's going to go, where are we here? This flip-flop here, the output is going to go right up here, come down, and go in this AND gate, which is enabled, right? The output is going to go through this OR gate and into the D input. All right? Now, which way is it shifting? It's shifting this way, isn't it? So when the direction input is high, this is shifting to the right, isn't it? Okay, now let's change it. Let's get rid of this here. Boom. All right. Delete. Delete. All right. Now, the next one, right? Suppose your direction now is low. Suppose this is a low. When this is low, these first gates we just talked about, well, you're going to have a low coming into them. So they're going to be disabled. I'm going to make that a D. That one's going to be disabled. That one's going to be disabled. And that one's going to be disabled. The drawing, you understand, those are all supposed to be Ds, right? My penmanship is just not that great. I'm sorry, folks. So, but if you notice this line, this is low. It's going to go through an inverter here, this NOT gate. And now this is going to be what? It's going to be a high, isn't it? If it's high, that means this gate, this gate, this gate, and this gate are all enabled, right? When I say they're enabled, remember, that means whatever comes in on the other input is just going to go right on through. If it's a 0, it's going to be a 0. If it's a 1, it's going to be a 1, okay? So, if you notice, if this second gate is enabled, where is this output going? It's coming up here. It's coming right down into this gate. It's going to come right on through into the input. So what was here is now here. You get it? Same thing's going to happen here. This one's going to come up here, come around. Now this gate is enabled. It's going to come right on through to the input of this gate. So this one, what was here, is going to come here. And the same thing obviously happens here. This one, when you output something, is going to come over through there, and this is going to be in their leftmost flip-flop. So what do you think's happening here? This one is going to be a shift left. Get it? Everything is shifting this way. So your direction can basically be controlled by this input, if it's high or if it's low, right? So one thing I didn't bring to your attention, we have the right shift in. So if you're shifting to the right, this is the feeder that feeds it. If you're shifting to the left, you have a left shift in, and this is the feeder that feeds this register. Obviously, you have to have bits coming in if you're going to shift to the left or shift to the right, and this is where they come in from. But basically, that is a standard bidirectional shift register. All right? All right, everyone. Thank you for watching, and I hope you have found this video helpful.